Now let's focus on relationships in our language. So I'm creating a vector of height of some people, right? So these are the heights of certain people who came for observation. Yeah, so X is the variable, row number 163, where we are looking at the height of individuals. Okay, so you have, say, some 10 observations. Another observations are there, the corresponding weights of those individuals, right? So X and Y. Now I'm building a relationship. When there is a dependent variable and independent variable, you can have one relationship. You might have studied in algebra, linear algebra, where if X and Y are there, two variables, and X is an independent variable, Y is a dependent variable, the relationship will be Y is equal to mx plus c. याद है वो formula? You remember that formula? Y is equal to mx plus c. Mx plus c. M is the slope and c is the intercept. Right? Y is equal to mx plus c. When you have learned the linear algebra in 6th standard or 7th standard, so this relationship is there. The same thing we are building here. So now we are building a linear regression. It is called linear regression, right? So we're building a relation between y and x. So for this, y, above the tab button you have that notion which is in a curved line. So y on x. So y is a dependent variable, x is the independent variable. So now we are printing a relationship. So this is the formula. So y is equal to mx plus c, where intercept is minus 38 and slope is 0.67. So this is being done. That means I have weights of some 8 to 10 individuals. Similarly, I have weights of 10 individuals and heights of 10 individuals, and I'm building relationship between this data, right? So now A, so I'm creating a data frame A for X is equal to 170. See, I have values 151, 174, 138, 186, 128, 136, 137, like that, right? I don't have 170. Suddenly an individual has come whose height is 170 centimeters. So now I will be predicting the result basis this relationship. So A, I am creating a variable x 170. Now I am predicting the result. So predict relation comma A. So based on the value of A, predict the relationship. So I get the value of result. The result will be 76 kilos. So if a person who is coming with 170 centimeters of height, his weight will be 76 kgs. So depending upon the data points which are there in X, the Y is predicted. So you see 170, are there any values close to 170? There is 179 and 174. A person who is 174 is 81 kilos. A person who is 179, he is some 76 kilos. So based on that, the relationship is built, and it is giving that a person who is having 170 centimeters should be ideally 76 kgs, depending upon the data points. Right? Now, so there is a girl by name Eureka. Her height is 165 centimeters. Now let us check what is her weight, right? So X is 165 and the result is 72 kgs, 72.8 kgs, right? So ideal, depending upon the data points, the weight should be like that. If you go to any hospital, you will have heights and weights, right? So that they would have calculated by taking average of several people. Now, another, let us create one predictor and response variable. So X points are there, then Y points are there. The formula is very, very simple. Relation is the variable that I am creating, where I am using LM. LM is a linear regression, where Y is the independent variable, X is the, Y is the dependent variable, X is the independent variable. Similarly, if you compare it with finance, interest is the independent variable, but yield on the bonds is a dependent variable. So like that, suppose if you have various interest rates and what are the corresponding yields on the particular bond. So you can calculate whenever there is any rate change. If RBI changes the repo rate, the interest rates will change. Then the bond yields will be impacted. So like that, the relationship is created, right? Now, what we can do is we can also plot it. We can also plot this. Okay. So X I am defining, right? Then Y I am defining, relationship I am defining. Now I am naming this file as PNG file linear regression PNG. Okay, now I will plot this. I will say that plot Y comma X, where color is blue, main is height and weight regression. Okay, so AB line is a relationship line. Okay, and CEX is what? The point character size. PCH is what? That is the characteristics is 16. X axis is weight in kg, Y axis is height in centimeters, right? So when I click this, okay, and I will do this def off, right? Yeah, so you got the plot here. Okay, now if you look at this plot, you will have an idea how the points are there. Say for example, the weight is in kg, similarly height is in centimeter, right? So your height is your independent variable, weight is a dependent variable. Based on the height is the weight. So this line which is there, the straight line, is a linear regression line. So you only have the data points. So this line is formed because of the relationship between your X points and Y points, the height and weight. Now you see what is a height of 70 kgs? 160 centimeters, right? 170 close to 80. So like that you can predict. So this is how you calculate the weight and height regression. So it's very, very simple. Only thing is you need to understand, you are defining Y, you are defining observations of X, you are giving a color, you are naming it a title, then AB line is your linear regression line. Okay, in the same plot. So plot is for points, line is for your regression line, right? Y is equal to mx plus c. So the point characters are 1.3 and the 16 and the point size is 1.3 and x axis and y axis. So this is how you are plotting a linear regression on graph. So similarly, if someone has given you some data points on rate of interest, you will put it in one vector x and yield in y and you can plot it. Just change the values and change the nomenclature. X axis you can say yield, y axis you can say rate of interest. So simple way you can create the regression line for yield and interest. So this is an example for height and weight because it is easily understandable.